So yeah, it's about time. We're in a time loop. So let's see how this works out this time. If I ask again now, who would know what this actually means? So lift your hands. I mean, I know that at least half of you are lying now. See, okay. So, and the other half, so everybody should know what this means, right? And I mean, the first thing is the second since the epoch until actually right now. And it's probably the standard way computers represent time. The second one is more the way that humans represent time. And, well, in essence, the talk is about how to get from the second to the first. Before I start, a few disclaimers. I'm still not a linguist. So I don't know. I mean, linguists for sure know a lot about time. Physicists know a lot about time. Sociologists probably also know a lot about time, meanings of time, the eternity, whatever. I'm rather an engineer, so I have a very practical approach here because I had a problem to solve and I couldn't find anything to solve it, and that was my way to solve it. Well, we use time a lot as humans, and well, I mean, one thing that probably differentiates us from a lot of other species is that we can actually reason about time, about the past, the future, things like that. And then if you have kids, you know that at least my kids, it took a very long time to realize what time actually means. So you get the chocolate later, whatever. No movies before 6. Well, and then, like, if humans communicate about time, it's more often than not, it's very ambiguous, right? If next Sunday, later, after lunch, it's not very well defined, at least not as well defined as the second since the epoch. Still, I mean, to communicate with the machine using natural language for humans is a very convenient thing to do, and maybe I'm wrong, but if you read the media, then, well, machine voice interfaces are becoming more popular, and at least the likes as Amazon and Apple and Google seem strongly to believe that we will talk with our computers in the future instead of using a keyboard. And then regardless of the mode of how we communicate, whether we type the text or we actually talk to the computer, if the computer is meant to understand that I want to book a table at a restaurant tomorrow evening, he somehow needs to understand what I mean with tomorrow evening. So then, like, if the machine is supposed to understand time, there are two challenges, obviously. The first one is it has to understand which parts of the language actually relate to time expressions, and the second bit, it needs to interpret these parts, make sense of them, and also in the context. And, well, ctparse is, it's a library that's basically a practical approach to solve the second problem, to, interpret time expressions. It's also, not get into much detail here, it's opinionated about how it treats time, to my company's use case, which is that we get messages from customers. It's about travel booking, and then it's very rarely that they reason about the past with us, right? They rather reason about the future, and usually they reason about the near future. The structure of my talk, it's basically two parts. The first part is the warm-up, like some background, some motivation. It should be comprehensible. The second part is about details, technical details inside the package, how it actually works. Might be a bit confusing, but I hope not too much confusing. Well, in Python as a programming language, every programming language actually has means to handle time, and like this RFC format here is probably amongst the most common ones. I guess everybody's seen that before. And in Python, we have the date-time module, so we have things like times, dates, date times, time deltas, and also some more advanced packages to deal with relative times and things like that, like 2 days in the future, 1 minute in the past. There are also some packages to parse, well-formed time expressions, like the date-util-date parser. If you parse it a well-formatted time string in basically any language, it will be able to transform it into a date-time object. And, well, there are actually very few, at least maintained packages that are able to parse less well-formed things, so things that do not like a formal time description. There's parse date time. It's only in English. As ChronoPython, slightly outdated. Yeah, and then finally there are some wrappers to standard NLP tools and like SU Time from Stanford. What is that? This is basically regular expression based. Only works in English, and it's very hard to get that running. There's a Python wrapper for that, but at least for me it crashes after 5 tries, and then you have to restart Python, which is no fun. And if you want to extend it, well, it's Java, so I don't know. And then another thing that is out there, it's called Duckling, and they themselves say it's a language engine and tooling for expressing, testing, and evaluating composable language rules on input strings, and especially also on times. Well, that's written in Haskell, which is much nicer than Java, but still, yeah, it's a bit hard to extend. But because it works actually pretty well, this is basically the blueprint for ctparse. And then maybe someone will yell at me now, but actually I'm not aware of any other packages that do this job reasonably well, which is kind of surprising because it's pretty common. So what do we want to achieve in the end? Of course, we want something that's able to parse well-formed expressions. So like properly formatted dates should be understood. Then there are named expressions, Monday, now, tomorrow, the end of months. We want to understand time ranges in simpler or more complex configurations, and then of course like combinations of all of that, like next Sunday evening after 6. And as I mentioned, you can use regular expressions, and it's actually, well, regular expressions make sense, because time expressions have many formalities. Even if it's natural language, more often than not, there are very formal bits in there. And that's, if it's formal, it's ideal to do regular expressions, and like the regular expression here would match anything that describes a numerical day, right? Anything that's from 0 to 31, probably with a 0 in front of it or not. And like a small detour for the computer scientists here, regular expressions, the expressive power is type 3 languages, and formally it's like you always have a non-terminal symbol that you can translate into a terminal followed by a non-terminal, and there are a lot of funky features in regular expressions like look-aheads, look-behinds, positive look-aheads, and things like that. I had to make like a small step back, so like type X language grammar, what does it mean? I'm talking about formal grammars and formal languages, and that's like the Chomsky things. And basically a grammar of type X is able to generate a language of type X, and a grammar, it's simplified, but usually it's a set of terminals. That's like the building blocks of your language, non-terminals, which are kind of intermediate things, and then there are rules to transform these non-terminals into something else. And the smaller the X, the richer the language. So type 2 languages are more powerful than type 3 languages. What we want to do here, of course, is not to generate language, but we want to parse language, but that's basically just the inverse problem, right? So if you have a grammar for something, then checking whether a sentence actually is part of your language is in the end building up the parse tree, and then if you have the parse tree, you know how to interpret. Well, regular expressions. They're very nice for small pieces, but as soon as things get, if you want to match more complex stuff, regular expressions tend to get a bit clumsy. I mean, this one is something that would match things like 12:34 a.m. or p.m., whatever. But now, I mean, if you imagine an expression that would also match at Monday the 25th between 5:30 in the morning and 15 o'clock in the afternoon, it will get very complex and very hard to maintain. So as an alternative, one could probably try to decompose the problem. So instead of building larger and larger and larger regular expressions, what SU time does in a sense, one could try to decompose the problem into smaller problems. So instead of doing this thing on the top, so like have a long OR of all sorts of regular expressions, and this can be endless in a way, which then probably gives you a daytime, just don't. So if you see something in your text that looks like a time and smells like a time, then why not just assume that it is a time and take this and try to combine with other things you find in the text. Which in a sense brings us to context-free grammars. They're more expressive than the regular expression. That's type 2 languages, and instead of being able to produce things where you have to produce some final symbol followed optionally by non-final symbols. They allow you to produce arbitrarily long sequences of terminals and non-terminals. And for example, you could have rules in that language which say a date time, where it's anything that's a time plus anything that's a date. And then you can specify various rules for how a date can look like. A date, well, like the typical day, month, year thing, or times, hour, minute. Well, I mean, what's positive about context-free grammars? They're more expressive than regular expressions. It's more compact in a way, so it's easier to navigate what you do. On the downside, they can produce more, right? So they have more ambiguities. There are multiple ways to more ways to pass the same string to different results. Well, and then there's no standard Python model to handle that. And well, when we even take that a step further, so there are probabilistic context-free grammars, and it's actually a really small extension, only saying that every rule has a probability attached to it, which means you can then, if you apply a sequence of rules, you can basically multiply the probabilities, and that gives you a probability for your production. So the higher the probability of your production, the more likely that's the correct one. And also, like, while you're searching for the solution, then you kind of use these probabilities to guide your search and do a depth-first search on the most probable path instead of a width-first search. Go back to ctparse. Is it a PCFG? And no, it's not. But it's very similar. The terminals in PCFG are regular expressions. So you have a lot, after we come into details a bit later, but you have a collection of regular expressions that basically describe the building blocks of your language. Anything that matches the regular expression can in the end be part of the production. And the non-terminals are the things we want to produce. And they're actually just two, times and intervals, but they are parameterized. So a time is basically a container also for partial times, and we get into details later. So in a sense, there's unlimited potential non-terminals and a limited set of terminals. And then I don't know why actually the last line of my slide seems to be missing, but the rules are still rules. So as a small intermediate wrap-up, interpreting time expressions has many applications. You can try regular expressions if you have to deal with only well-formatted times, but things might get a bit unmaintainable after a while. Using probabilistic context-free grammars is probably more intuitive, more maintainable, and yeah, there was no Python package until now. So how does this ctparse beast work? And now it gets a bit more dirty. So as I said, there are basically only two types in ctparse. One is a time, and one is an interval. And in these types, everything is optional. So the time is really just a wrapper around the time. The time can be anything that is a month. August is a time, or 2018 is a time. But then, like Monday, day of week, that's what DOW stands for, is the time, or expresses the time, and POD, part of day, late afternoon could also be a time. And intervals are really just two pairs of time. And everything can be missing, so an interval can be left open or right open or closed. Well, and the rules, as I said, they are really just, they're expressions saying that if you find something that matches morning, I mean, that's like the most simple rule you can think of, probably, then you say, okay, then it's maybe a time where the part of day is morning. Or the rules say if you match a sequence of at and then something that is a time, then you just ignore the at and say it's still the same time, right? I mean, whether I say I want to meet at 5 or 5, that doesn't change the time I'm talking about. If you now wonder where the connection to the grammars is, you just have to read that the other way around. So what's returned here, that's the non-terminal, and the left-hand side and the right-hand side of the productions is what's in the rule thing, right? So this basically says the time can be a regular expression morning, or a time can be a regular expression followed by something that's a time. So how do these rules work? I mean, they can be regular expressions, That's probably the simple bit. And other than that, the rules are the sequences of regular expressions and intermediate productions, and the rules refer to properties of the intermediate productions in ctparse. You can say, you can apply the rule if there is something that is a time, or you can apply the rule if there is something that is a day of the week, or there you can apply the rule if there's something that has a year, right? So could have more, but at least you know that the time you already passed knows what year it is. And then these rules are applicable if and only if you can match the sequence of these regular expressions and productions, like somewhere in your intermediate production. And then, of course, if the production itself doesn't fail. I mean, that's another thing that's not part of context-free grammars, but the rules themselves have a semantic, right? If you want to produce a date from something that's actually can't resolve to a date, because it's like the 29th of February 2018, which does not exist this year, then you can't produce that. So from that setup, if you now think a bit about it, then okay, all the terminals are regular expression. Like everything we can, all the strings that the grammar can produce, or all the things that we then can parse, have to be regular sequences of regular expressions in the end. If that's true, then like a first step, what one can do is we could just go in all the rules, collect all the regular expressions, match all these regular expressions. Oh no, actually, yeah. And then basically just see, do we find sequences of matching regular expressions? That's basically what I just said, right? So if everything we can produce in the end is a sequence of regular expressions, all we have to do is basically find all the matches of regular expressions and then see which of them make sense and which don't. So to make that a bit more griffig, let's parse the string July 8th, 2018. So what ctparse does first, it takes all the regular expressions from all the rules, and these numbers here actually refer to actual expressions in the library, and just finds all matches of them, okay? So in the string you can match July as a month, you can match just the 8 as a month, or you can match 8ths as a day of month, and then 2018 you can either match it with the regular expression that's meant to match a year, or you can match it with a regular expression that's meant to match a time, like 18 minutes past 8. So once you got all these matches, as we've seen, these matches, they overlap, right? So the M4 and M5, they just match the same text. So there are multiple solutions, obviously. And for us, it's clear that this is a year, but for the machine, of course, it's not, right? And you could even argue that July 8th, 2018 might refer to July 8th at 18 minutes past 8. I mean, it's pretty unlikely, but so to keep that, we now go and take all these matches of regular expressions and try to find all the sequences of these regular expressions that do not overlap. And as it turns out, for this example, there are 3 of them. So you can represent the sentence July, or the bit July 8th, 2018 by 3 different expressions, 3 different sequences of regular expressions. As I said, once with the year in the end, once with the time, and the third one actually ends at the 8, because then there is this unmatched bit, the th, and then it's over. So and we just put them all on a stack. And then, well, we go and apply productions. So you take one element from your stack, and then you test each rule. Can it be applied somewhere in the sequence of this intermediate productions? And if so, you apply the production and produce a new element that you put on the stack. What does it look like in a small example? So if you take the S2, which happens to be the correct one in the end, that's the sequence on the stack. And then there is the rule month July, which just says if you find the string July, it's probably a time where the month is 7. And then you produce, well, a new stack element, S4, where you just replace the expression that you matched by the production. And now it reads time and time month 7 plus 2 regular expressions that are still open. And well, surprise, surprise, there's a rule that matches the day of months and just says, okay, if you see something like 8, then it's also a time. It's the 8th day of a month, and this gives you a new stack, which now basically says, okay, there's a time which represents a month, there's a time which represents a day of a month, and then there's still a regular expression left. And okay, well, man, surprise again, there's another rule which says if you have a month and a day of a month, then you probably mean the day of that month and not of some months, right? And then you say, okay, then you're probably talking about 8th of July, and then the rest is probably quite obvious. You have an expression that says 2018 could be a year. You put that on the stack, and then you have a rule that says if you have a day of a year, like the 8th of July without a year and a year, then these two together give you a more or less full qualified date at least. Whoop. Okay, there was no P here. There was nothing probabilistic, but that's actually just a small hack then in the end, right? I mean, you can just assume all rules are equally probable, and so to begin with, and then, I mean, if you've seen that, then at each step of the production there is a sequence of, in the beginning there's just a sequence of regular expressions, and then you apply a sequence of rules on top of that expression, and if you just take the names of these things, this is basically a sentence again. And then if it's a sentence, then maybe you could do some machine learning, some NLP, and try to apply a model that tells you how likely is this sentence, like the sentence R10, R25, R9, P12, P1, P3, how likely is this sentence to produce a correct resolution in the end, something that actually that is the thing you've been looking for. And I won't go into details here, but what ctparse does, we keep it simple, and it's just a naive base classifier that gets n-grams over the sequences and then is asked to predict how likely is this sequence to result in something that's actually correct. And yeah, so I mean, if you do machine learning, then obviously you need some data to do machine learning on, and as I mean, one part of ctparse, apart from all the algorithmic bits, is the rules, and then another part is something that's called corpus, and the corpus is basically just a collection of input strings plus the expected resolution of these strings. So what is a correct way to interpret that string? And then you can just take that data, run it through the system, and check, does the system actually produce the right thing? And for all the pairs where it's correct, you say, okay, this is the sequence that will lead to the correct result. For all the pairs where you produce something wrong, you have a counter example and say that's a negative sample. Disadvantage is that if you do something in ctparse, if you change a rule, if you add a rule, if you modify something, you have to build this model again, which is it's part of the package. And actually, it's important that the model matches your rule set, because otherwise, it will just predict bullshit. An advantage is that this also serves as a unit test, right? You have a big collection of samples on how you expect your package to behave, and well, if you can't produce the correct resolution for anything in your sample, then something is wrong. So how well does that perform? I mean, the problem is it's a bit difficult to compare, and I mean, unless now somebody disagrees and says, no, there's package XYZ which excels at interpreting time expressions, there was basically only duckling to compare against, and the comparison here is on our internal data, which is a set of about 40,000 strings that express time. And someone took the burden to apply labels to each of them and say, okay, this string means yeah, and well, I mean, ctparse seems to perform quite well. So it's there are two things you can ask: is the highest scored solution, is that one correct or not? And it's slightly better than duckling. The other thing you can ask is it able to produce the correct solution, even though it probably doesn't say that this is the most probable one, and that is even better than duckling currently is. And I mean, we don't use that tool, the ctparse, in our product yet, but we will do so within the next months, and I could imagine that this will get even better. So all theory is futile. Let's have a quick sample here. And actually, I forgot to restart this. It looks a bit ugly now. Let's start from scratch. Just to show that it actually works. Huh? It's difficult to look there and type here. So you can just import it, and then you ask it to parse something, and that's what you get, right? It says tomorrow it's the 8th of July, and this is, I mean, it's still in alpha mode, so it gives you a lot of information that you probably won't need, but the S means it's scored with 1 point something, and the production was, say, okay, you apply the regular expression 151, and then you apply the rule tomorrow. Could do tomorrow evening, so then it says, okay, it's still 8th of July, and then these XX means the times are not specified, and the other two X's in the brackets, the first one refers to the day of week, which is not given here, but the second one to the part of day. And this tells you that this string means something on the 8th of July in the evening, and then it's actually up to you to say what evening is, right? And the production, you also see here, it's like 2 matching regular expressions, and then 3 rules were applied to get to that. And let me try something more complex. 12ths to 15ths. I'm sure this is going to fail now. No, it's actually not, right? So this gives you an interval. It's 2 times now, and basically the same thing as before. So it says it's from the 12th of July to the 15th of July, and just a bunch more of rules. Yeah, I mean, if you want to get it, it's the usual ways, right? You either clone the GitHub repo, or you do pip install. Maybe you read the docs, which need some improvement. And now, I mean, I hope you're so excited. And can you contribute? Yes, you can, of course, right? I mean, so far it's basically our internal effort to get that running and improve it, but there's a lot of things that can still be done. I mean, as I said, if you compare that to Duckling, Duckling is much more flexible in what it can parse. It does not only handle times, and especially it handles multiple languages. I didn't mention that, so ctparse is built to be language agnostic so far. It's only targeting German and English, and since German and English, apart from some, actually one ugly detail, that's the order of what's the day and what's the month, the expressions are very similar. It could easily be extended to handle other languages. Like, I mean, if you add French, then probably you have really different ways to express stuff, or Chinese, or whatever. And actually, this day-month thing is not a big problem for ctparse because, as I said in the beginning, it's opinionated about the kind of expressions you try to parse. So it's meant to parse things that happen now, not parse the Bible and reason about who was born, or like whatever, Lord of the Rings, and then try to reason who was born when and was the blah blah of something. It's really just meant to say, okay, if you talk about time now in real world, which time could you mean? And this is usually in the future, right? And then you can actually, there are very rare cases where it's not clear what's the month and what's the day. Well, speed could be optimized. There are a lot of rules which are still missing, which we know. So there's many things one could do. So if you feel like it, have a look and have fun.
Are there any questions?
Thanks. Thanks for the talk. Really interesting work. So I'm fighting with very similar parsing tasks at work. And what I wanted to ask is twofold. First of all, is there a tutorial available how to define your own rule sets and your own grammars?
No, but I will add one next week.
Okay.
I actually thought it would be clever to do that before the presentation, but I just didn't find the time.
No problem.
It's actually quite simple.
It's really cool. And my second question would be, my colleague just asked me, like, what happens if you have a document that is written at a certain time frame and says tomorrow? Is there any way to tell the model or the parser what the context, the time of the context actually is?
Yeah, I didn't show in the small demo. You usually have to parse in a reference time. So you can you say what is now, and then everything is interpreted relative to that now.
Cool, thanks.
Thank you for the interesting talk. The German support, the support for German dates, does that work out of the box? Because I just looked at your documentation on Read the Docs, and I couldn't find anything how to enable a language in there. Do I just give it a German text and it's fine? Or?
Yeah, as I say, currently it's language agnostic. So, I mean, that's basically practical reasons, right? I mean, like at Comtrabo, we basically only support German and English messages so far. And we have a really big NLP pipeline to understand what people ask for. And in most cases, we actually figured out that it doesn't really make a difference whether we build two different models, one for German, one for English, or whether we just build one model. And this also holds true for the times to a large extent. So right now, there's just one set of rules that applies to German and English, and it doesn't really matter. But as I just mentioned, like in the future, it would be easy and probably useful to actually at least parse in the language and say, okay, this text is whatever in Korean, and then either have a separate set of rules to parse Korean time expressions, or have some way to specify, well, to select a subset of the rules, or change the weights, for example, right? And say, this is a very common thing in Korean, but never appears in German. So if you already know it's Korean, then you might get different results, right? Or same thing, German-English, daytime, the day and month order. If you pass in the information that this is English, or probably even whether that's British English or American English, because I mean, I don't know which is which, right? I think the British actually do day, months, and the American do months, day, right? Then you, of course, could use that to just pin down the correct solution.
So thanks for the talk. Could you, should I be standing? Could you talk a little bit about what sort of cases it fails on? So, you know, the 32% where it gets it wrong, like what do those cases look like?
There's one type of failures which is related to speed, I would say. It has a built-in timeout parameter which you can freely set. And you can generate cases where if you don't set that parameter, it will just go on and on and on and on, and then maybe 20 minutes later you get a response. It's a generator, right? So you get the first response pretty quickly, but it will still just go on and on and on and produce more and more and more resolutions. And I guess that could be helped by actually improving the model that's in there, because this naive Bayes it's really naive. And there are probably also ways which are way more clever than just looking at this production sequence. It doesn't look at all on, like it says, like right now it really just says the initial sequence of regular expressions was this, and then you applied these rules in that order, but it ignores that you also know to which expressions you actually applied the rules. So it doesn't look at the tree. Then other things, it does not handle typos well. Actually, not at all. Would be doable on the regex level. You could just say, okay, I allow some added distance here in the regular expression, but then on the other hand, it increases the number of potential parsers, so it's a trade-off here. And it also, like if you parse in really not well-formatted strings, that's also not very advisable. There's a small normalization function baked in, which should probably go somewhere else, because that should be someone the user has to take care of. But if you have some funky UTF characters, that screws up all the matching. Other than that, of course, there are, as I said, there are quite a few rules. We are aware of that they're missing, but it parses quite a bit.
Hello, I'm here. Up here. Yeah, thanks for the talk. I have just one question. You manufactured the rules, and did you think of a way to generate automatic rules based on the failures?
How would you do that? It sounds like an interesting idea. But
part of my question.
There are ways. What we try to do. There's nothing to do with the way we do it here, right? There was a paper, I forgot by whom. They trained a model to parse times, right? You give it a string, and then you discretize time by whatever you're willing to do, like say whatever half an hour buckets, and say, okay, whatever I try to predict is within the next half an hour. That gives you something like 2,000 classes, and then you try to classify the strings into which bucket they belong. We tried that, fails. It didn't work well. And then automatically get rules. No, I wouldn't know how to do that. At least not how to do meaningful rules. This is also like doing these rules is, on the one hand, it's very easy. You can just, when you see something that doesn't pass, and then you basically can just say, okay, then let's write a regular expression that would match that thing, or match the bit that doesn't get picked up, and then just try again. But then there are a lot of dependencies, right? Then this rule might also match things that you actually don't want to match and produce false positives, or might increase the search space unreasonably. Sometimes it's really, if you have small typos in a rule, if you happen to add a rule that matches, I don't know, you mistype and it matches a dash for itself, then of course this gives you a lot of more unique sequences, because you can suddenly go and say, okay, there's like initially there's another sequence that could be in the initial stack which matches the dash here, and then there's like 10 roots which also match the dash, and then, well, the search space explodes. But I mean, if you have any idea how to do that, then let's talk.
Hi, thanks for the talk. I have a question. There's a Python package called Pendulum. I don't know if you've heard about it. So it's used to sort of parse datetime format, but not from like generated language, but more or less standardized. So the question is, have you heard of it? Because I think you could sort of use it as a first level to just maybe the time string is actually standardized. That would be easier to extract it. And if that doesn't work, we use like your solution.
I've heard of it. Since it was not on the slide, I forgot about it. Yes, I mean, but again, I mean, as if I understood you correctly, you also say this is mainly targeted at well-formed expressions, huh? Like the date util date parser. So if it looks like at least like the way you would write a date in a letter to your mother, then it will get it. But if it's slightly different, it will not, right? And of course, you can always just try to check whether this matches some simple regular expressions, and then no need to use a tool like this. But I'm a lazy guy. I mean, if you put in something here that matches a typical way to write a time, it's also very, very fast. It would just take a few milliseconds to give you a response. So I guess there's not really a lot of use for that. Okay. Another thing an issue we have here with the times is that if people write an email, they usually then don't write an email, and more often than not, they don't write an email and say, okay, I need a flight, and then they write a proper date and a time or something that all sits together in a consecutive part of the text, but rather goes like, I will fly to London next week. I need to be there at Monday morning, but not later than 10. And then all these pieces that actually make up the time are scattered around in the text, and you get some noise in between. And we just use some standard entity tagger to find the pieces that belong to time expressions. But then if you stitch them together, there's usually some noise in between, right? And
Hi. Have you thought about incorporating like a mutable timeline in your expression? So what I mean is you can preset your now, you've said so, but what if the speaker kind of resets that for you? So let's say that I want to say I took drug X for 3 months 2 years ago.
Yeah, I know. It's like
I'm just asking if that's
really
possible.
This depends on what you want the library to focus on, right? I mean, this library, it's at least currently as it stands, the focus is not to do that level of reasoning. It's really on that level that you have identified a piece of text where you say that is a time expression. I just want to know what it means. And then if you have these scenarios where you really have to reason in the bigger context of the text, like because time moves back and forth, like the reference time in the text moves back and forth, that would need to be handled externally. I guess it would be very difficult to do, right? I mean, it's like not very difficult. I mean, of course, there are approaches to do it, but I guess you have a trade-off between saying I'm either very precise on these small snippets, or you're able to handle these more complex relations between different time expressions in a longer text. But I get my personal feeling would be that's better handled outside of the thing that tries to understand a little bit. I mean, what we do is, like if we read these messages, we start at the message date when we receive the message, and then like let's say we hit the first time, and we also know let's say we also know that this refers to the departure time of some flight. And then once we pass that time, we advance the reference time and say, okay, anything that happens afterwards, at least like if then the next thing the person asks for is a hotel, is relative to or wants a return flight, is relative to the departure time. You don't want the return flight before the outbound flight, right? But this is really just heuristics which are very specific to our case.
Are there any more questions?
Since we started 2 minutes early, we don't want to stop 2 minutes early, right?
Hi, actually, I was just wondering how you arrived at this particular design or architecture, and what are the things that you tried that didn't work?
I'm
just wondering what are the things that you tried that didn't work?
What we tried that didn't work?
Like, rather than this particular sort of setup. Thanks.
Well, I mean, we tried all the libraries I mentioned.
Okay.
And I mean, so far we actually just use duckling, which is really painful. But yeah, and then, well, this classification approach we tried, but well, other than that, we just spend time on this and hope to get this to a point. I mean, it's already at a point where we can make use of it, and well, and I think there's quite a bit of potential.
So, if there are no more questions, then thanks, Sebastian, for